Hello all, welcome to my channel Crystallized Science. So I am here with a new video of maths. That's to find maximum and minimum value for a given function, and this topic is related to the engineering students. That is, it comes in maths in semester 1, in semester 2 of engineering, as well as it also comes in syllables of 11th and 12th science. So this is the most important question that is asked in exam, that is how to find maximum and minimum value for a given function. So I have prepared a flow chart so that it makes easy to find the values for a given function, right? So let's start. So if you are given a function f of x, then first step is to differentiate it with respect to x. So the value which you will obtain is nothing but f dash of x. Then in second step, you just have to differentiate it again with respect to x, right? You have to differentiate again with respect to x, and you will obtain the value as f double dash of x. Now in third step, which is most important step, is to obtain value of x1 and x2. How can you obtain the value? You have to suppose that f dash of x is nothing but equal to 0. Then you have to solve whole function, right? And you will obtain value of x1 and x2. Then last second step, that is you have to substitute this value in the two functions, that is f of x and f double dash of x, right? And at last, when you will substitute the value of x in our main function, that is f of x, then you will easily get maximum and minimum values, right? So these were the easy steps that you can follow to find maximum and minimum value of any of the given function, right? It can be in the algebraic form, it can be a trigonometric form, right? You can find easily by using this method, and you have to solve it step by step, and we will further solve the numericals based on this. Okay, thank you. So let's try out one numerical. It is to find maximum and minimum value for a given function, that is x cube plus x square minus x. So let's start. F of x is equal to x cube plus x square minus x. So first step is to find the single differentiation with respect to x. So d by dx of x raised to 3 plus x raised to 2 minus x. So we will use one common differentiation formula for power, that is, if a given function is in the form of x raised to n, then we can use it as nx raised to n minus 1. Okay, so we will apply this formula. So we will apply this formula for three terms, that is d by dx of x cube, d by dx of x square, and also for d by dx of 1. Okay, so let's see. So here for d by dx of x cube, according to the formula, it will become 3x raised to 2 minus 1 plus 2x raised to 2 minus 1, and differentiation of common term is nothing but 0. So answer will be 3x raised to 2 plus 2x. Okay, so the first value which is obtained is for f dash of x is 3x square plus 2x. Now again, the second step, this is second step, this was first step. Okay, and so for second step, what we will do, we will again differentiate the f dash of x with respect to x, right? You have to only differentiate with respect to x. There is no need to differentiate it with another variable, right? So let's continue. D by dx of 3x square plus 2x. So what we will do, we will differentiate both of this term individually, right? So d by dx of 3x square plus d by dx of 2x. Okay, so now applying the same formula, that is nx raised to n minus 1, power will come down and it will be decremented by 1. So 3 multiplied by 2, x raised to 2 minus 1 plus 2, x raised to 1 minus 1. So answer will be 6x plus 2. as x is to 0 is nothing but 1, right? So let us continue. So we have obtained two values, that is f dash of x as 3x square plus 2x minus 1 and f double dash of x as 6x plus 2. So now let's begin with third step, that is we have to obtain the value of x. So for obtaining the value of x, what we will do, we will suppose that f dash of x is nothing but equal to 0. That means 0 equal to 3x square plus 2x minus 1. So here we will use middle term splitting method, that is 3 1s are 3. We have to obtain middle term as 2. So we will split middle term as, okay, we will take common things outside. So 3x, x plus 1. Here there is no common, so 1 will be common and x plus 1. So here two factors will be obtained, right? So we will apply 0 to 3x plus 1 as well as we will apply 0 to x plus 1. So we will obtain x as minus 1 by 3 and another value of x will be equal to minus 1. Okay, sorry, it is minus 1, so plus 1 by 3 and minus 1. Now what was the fourth step? Fourth step was to substitute this value. We will substitute x1 and x2 in f double dash of x, and at last we will substitute the same value in f of x. So let's start. We will substitute in f double dash of x, that was obtained as 6x plus 2. So we will substitute here x1 equal to 1 by 3, that is 6 into 1 by 3 plus 2. 3 2s are 6, 2 plus 2, answer is nothing but 4, right? Again we will use same value for our main function, that is x cube plus x square minus x. Here 1 by 3 whole cube plus 1 by 3 whole square minus 1 by 3, that is 1 by 27 plus 1 by 9 minus 1 by 3. As you all know, LCM of 3, 9 and 27 is nothing but 27. So 1 plus 3 minus 9 divided by 27, answer will be minus 5 by 27, which is less than 0, and we have obtained minimum value. This is nothing but your minimum value. Okay, now we will proceed towards maximum value. So for maximum value, let us substitute x2 equal to minus 1. So what will be f double dash of x? It is 6 multiplied by minus 1 plus 2, that is minus 6 plus 2, answer will be minus 4, which is less than 0. Now our last step is remaining, that is we will substitute x2 equal to minus 1 in our main function, that is x cube plus x square minus x. We will substitute x as minus 1, so f of minus 1 is nothing but minus 1 cube plus minus 1 square minus 1. Here you can see, as the power is odd, so value will be minus 1, power is even, value is plus 1, and here same, minus 1. And also we have to remember that we have to substitute minus 1 over here. So minus 1 plus 1 plus 1. So at last you will get minus 1 plus 2, answer will be 1, which is greater than 0. So here we have obtained two values, that is we have got minimum value as minus 5 by 27 and maximum value which we have obtained above, that is 1. This is less than 0 and this is greater than 0. So this is the easy method that you can use to find maximum and minimum value. So let us evaluate another numerical, that is given as for function f of x equal to sin x plus cos x. If the angle of x lies between 0 to 360 degree, then we have to find the maximum and minimum value of the function, right? So first we have calculated numericals on algebraic functions. Now we are calculating it for trigonometric angles, right? So let's see. First steps, it is you have to differentiate it with respect to x, that is d by dx of sin x plus cos x. We have to individually differentiate it, sin x, as well as I will apply this function to cos x also. As you all know, the differentiation of sin x is nothing but cos x, and differentiation of cos x is nothing but sin x. So here I have obtained first equation of f dash of x as cos x minus sin x. Now let's proceed to second step, that is to double differentiate it. Double time differentiation means the differentiation of the initial function, right? So let's try it. So d by dx of cos of x minus sin of x. So what we will get? The differentiation of cos of x is nothing but minus sin of x, and sin of x is nothing but plus cos of x. So this is the second equation that we have obtained, that is double differentiation value, right? Now we will proceed toward our third step, which is important step, that is to obtain x1 and x2 value. So what we will do? We will suppose that f dash of x is nothing but equal to 0, that is cos x minus sin x is equal to 0, right? Now I will place cos x to RHS, so minus sin x is nothing but equal to minus cos x. So if cos x comes down to the denominator on LHS, then RHS will become 1. Now as you all know, sin x by cos x is nothing but tan x, that we have studied in 10th standard, right? That tan x is equal to 1. Now you remember in which value of tan you will get value as 1, or on which angle of tan you will get value as 1. So if you remember it, then x equal to tan inverse of 1, you will get x equal to 45 degree. Okay, so x2 is nothing but 180 degree plus 45, that is equal to 225 degree. Okay, so we have obtained x1 as 45 degree and x2 as 225 degree. Now we will substitute both of these value in given functions. That was our fourth step, that is we will substitute x1 and x2 in f double dash of x and our main function, that is f of x. Let's type for x1 equal to 45 degree. So what was our f double dash of x? That is minus sin of x minus cos of x. Now I will substitute x as 45 degree. So minus sin 45 degree minus cos 45 degree. So minus 1 by root 2 minus 1 by root 2. Answer will be equal to, what will be the answer? It will be equal to minus 2 by root 2. So our final answer will be minus root 2, which is less than 0. Okay, so let us proceed further. I will substitute this same value for our main function, that is f of x. So f of x was nothing but sin of x plus cos of x. I will substitute x as sin 45 degree plus cos 45 degree. Now remember the value of sin 45 and cos 45 again. So 1 by root 2 plus 1 by root 2. Answer will be equal to 2 by root 2, and final answer will be root 2, which is greater than 0. So one step is over. Now, so we have obtained x1 as 45 degree and x2 as 225 degree. Now we will substitute both of these value in given functions. That was our fourth step, that is we will substitute x1 and x2 in f double dash of x and our main function, that is f of x. Let's type for x1 equal to 45 degree. So what was our f double dash of x? That is minus sine of x minus cos of x. Now I will substitute x as 45 degree. So minus sine 45 degree minus cos 45 degree. So minus 1 by root 2 minus 1 by root 2. Answer will be equal to, what will be the answer? It will be equal to minus 2 by root 2. So our final answer will be minus root 2, which is less than 0. Okay, so let us proceed further. I will substitute this same value for our main function, that is f of x. So f of x was nothing but sine of x plus cos of x. I will substitute x as sine 45 degree plus cos 45 degree. Now remember the value of sine 45 and cos 45 again. So 1 by root 2 plus 1 by root 2. Answer will be equal to 2 by root 2, and final answer will be root 2, which is greater than 0. So one step is over. Now let us proceed to another step, that is we will substitute x2 equal to 225 degree for f double dash of x as well as f of x. So f double dash of x is minus sine x minus cos x, that is minus sine of 225 minus cos of 225. Okay, so we will take minus sine of 180 plus 45. Yes, I can write, because 180 plus 45 is nothing but 225 minus cos of. So we have obtained x1 as 45 degree and x2 as 225 degree. Now we will substitute both of these value in given functions. That was our fourth step, that is we will substitute x1 and x2 in f double dash of x and our main function, that is f of x. Let's type for x1 equal to 45 degree. So what was our f double dash of x? That is minus sine of x minus cos of x. Now I will substitute x as 45 degree. So minus sine 45 degree minus cos 45 degree. So minus 1 by root 2 minus 1 by root 2. Answer will be equal to, what will be the answer? It will be equal to minus 2 by root 2. So our final answer will be minus root 2, which is less than 0. Okay, so let us proceed further. I will substitute this same value for our main function, that is f of x. So f of x was nothing but sine of x plus cos of x. I will substitute x as sine 45 degree plus cos 45 degree. Now remember the value of sine 45 and cos 45 again. So 1 by root 2 plus 1 by root 2. Answer will be equal to 2 by root 2, and final answer will be root 2, which is greater than 0. So one step is over. Now x minus cos x. We will substitute x as 225, same way for cos 225. Okay, so that is minus sine. I can write 180 plus 45. Same way for cos, I can write 180 plus 45. Now there is one rule for cos 180 plus theta, we can write minus cos theta. Same way for sine 180 plus theta, you have to write minus sine theta. So here answer will be minus sine of 45 degree, as well as there is minus, that is minus cos of 45 degree. So what will be the final answer? That is sine 45 degree plus cos 45 degree. So what is value of sine 45 plus cos 45? That is 1 by root 2 plus 1 by root 2. So final answer will be 2 divided by root 2. So 2 divided by root 2, the answer will be root 2, which is greater than 0. Now last step is remaining, that we have to substitute the same value for our main function, that is sin x plus cos x, that is sine of 225 plus cos of 225. Okay, so sine of 180 plus 45 plus cos of 180 plus 45. We will use the same rule which we have used above, that is minus sine 45 minus cos of 45. Minus sine 45 minus cos of 45 means minus 1 by root 2 minus 1 by root 2, that is minus 2 by root 2. Answer will be minus of root 2, which is less than 0. So we have obtained maximum value as root 2 and minimum value as minus of root 2. Okay friends, thank you. Do like, subscribe, comment and suggestion are always welcome for this video. I will make more videos for the engineering sums. Thank you all.